All right, guys, this is your Chapter 1 practice test. So, like I said in class, I'm just going to run through all the problems. We've got 1 through 25, this whole page, so feel free to pause, rewind, skip ahead, whatever. So starting with number 1, this is an evaluation problem. So here is the original, and then they give us our values of x equals 3 and y equals -1. Okay, so what you do for these, they give you these values, you take them, you plug them in. So everywhere you see an x, you're going to plug in the 3, right here and right here. Every time you see the y, you're going to plug in the -1. So let's rewrite this just with the numbers plugged in. Anytime you plug something into an exponent, you're going to want to put parentheses around it. And then 2 plus 3 for x. So follow the order of operations. First thing we're going to do is look inside any sets of parentheses. So we've got one right here. So this equals 3 plus -1 squared. And then inside the parentheses, 2 plus 3 is 5. So I evaluate that. Next thing in the order of operations is exponents, so I need to evaluate this exponent right here. So that will equal 3 plus, and then -1 squared. When I take a -1 and square it, it comes out positive. So that's going to be a +1, and then times 5. So the implied operation here, when I have 1 and then a 5 in parentheses, that's implied multiplication. So the next thing I do is the multiplication. So 3 plus, and then 1 times 5, of course, is just 5. And then finally, I add those two numbers together. 3 plus 5 gives me 8, and that is your final answer. Okay, next, number 2. We want to simplify the following expression. So we've got -4, and then in parentheses, 3a plus b minus 2 times a minus 5b. So the first thing we're going to do is we are going to distribute the -4 to the stuff inside the parentheses. We're going to distribute the -2 to the stuff inside the parentheses. So be super careful here, because when you distribute negatives, you've got to make sure that you distribute the negative to both of the pieces inside the parentheses. So -4 times 3a, that gives us a -12a. -4 times b gives us a -4b. Then next we distribute the -2. So -2 times a is a -2a. And then -2 times -5b is a +10b. Because remember, a negative times a negative always gives us a positive. So then next we're going to combine like terms. So I have -12 that I can combine with a -2a. -12 and -2 gives me a -14a. Then a -4b and a +10b. That leaves me with a +6b. So that would be my final answer there. Okay, number 3, we've got a multiple choice question here. This says if 3m plus 5 equals 23, what is the value of 2m minus 3? Okay, so what this one allows us to do is we solve for m. We solve that equation, we get the value of m. So let's start there. Subtract 5 from both sides, so 3m is then equal to 23 minus 5, which is 18. And then to get the m by itself, we can divide both sides by 3. So I end up with m equals 6. So that's the answer to this equation, but that's not the answer to the question, because there's still one more step that we need to do. So knowing now that m is 6, we want to know what is 2m minus 3. So we take this 6 and we plug it in for m, and then simplify down. So 2, and then plug in the 6, minus 3. So first we multiply the 2 times 6 together, and we get 12, and then you subtract 3. 12 minus 3 gives us an answer of 9, which on the multiple choice was letter B. Next, solve. So we've got this formula that we start off with. And it says they want us to solve for p. So what that means is that for our final answer, we want p equals, and then we want everything on that side of the equation. So right here, the p is being multiplied by an m squared. It's being multiplied by a 1/2. So we're going to divide both sides by 1/2 times m squared. Same thing on the left, 1/2 times m squared. So on the right, these things will cancel out. So now let's take a look at exactly what this left-hand side is doing. So we have r divided by 1/2 times m squared. Dividing by 1/2, this part's a little tricky, but dividing by 1/2 is the same as multiplying by 2. So instead of putting a 1/2 in the denominator, which we don't ever really want to have a fraction in the denominator, dividing by 1/2 is the same as multiplying by 2. So this is actually the same as having a 2 in the numerator. So instead of taking r and dividing it by 1/2, we're taking r and we're multiplying it by 2, which is exactly the same. So this says that p is equal to 2 times r divided by m squared. So these two equations are exactly the same. the original one that I started with and this one. I just rearranged this one so that the P was first instead of the R. 5, we've got a couple of expressions that we're going to translate into math. These are our English to math translations. So this says twice the difference of a number and 11. So if we want twice the difference, we need to make sure that the difference is isolated. So the difference of a number and 11, we can write n minus 11, but we want to take twice that, which means after we find that difference, we want to multiply it by 2 on the outside. So that one, you got to be really careful that you actually do have the n minus 11. If we wanted it to be 2n minus 11, that would be the difference of twice a number and 11. But since you want twice the difference part needs to come first. It needs to come in parentheses like that. Do number 6 right here. The product of the square of a number and 5. Product means you're multiplying. So the square of a number would be the number squared. And then the product of that and 5 would be times 5. You never really see it like that, though. Usually when you're multiplying a constant, it looks like this, like 5n squared. So that would be your answer there. And remember, I'm using n. I just keep using n for number. It really doesn't matter. If you want to use like a q or a g or an s, it really doesn't matter at all. I just use n or x, whatever. 7, we are evaluating this absolute value expression. Looks like this. And then it says if y equals 2.5. So same thing as we did with number 1. We are going to replace this y right here and this y right here with a 2.5 and then simplify everything down. So 2, and then the first thing I do is I'm just literally replacing each y that I see with a 2.5. So when we talk about order of operations, remember that the absolute value symbol is also technically a grouping symbol. So I need to simplify everything in here first. So isolating myself to just this stuff, first I'm going to multiply the 3 times the 2.5, and 3 times 2.5 is 7.5. So start there. So 3 times 2.5 is 7.5, and then minus 8, still inside the absolute value, plus 2.5, which if I continue to simplify this up, when I do this subtraction, 7.5 minus 8, that ends up giving me a negative 0.5. Okay, then the next thing I'm going to do is I'm going to take this and simplify up the absolute value part. So remember the way that absolute value works? Even if you've got something that's negative inside the absolute value, it always comes out positive. So the absolute value of negative 0.5, that means we want to know how far negative 0.5 is away from 0. And its distance would just be a positive 0.5. So the absolute value of negative 0.5 is positive 0.5, and then I add 2.5. So back to the order of operations again. Remember, I multiply these two together first before I add. So 2 times 0.5, that's 2 times a half, and 2 times a half gives us 1, plus 2.5, and then finally we can add those together, and we get 3.5, and that is our final answer. Okay, solve and then graph on a number line. Let me flip for this one. Okay, so number 8. Okay, we've got negative 2b is greater than 18 minus b over 5. So this is just like your normal inequality. There's no absolute values on it yet. So we're trying to get the values of b by themselves on one side of the equation. We need to start with this 5 over here. It's really kind of messing us up. So we're going to multiply both sides by 5. So do the same to the left. The ones on the right will cancel out because I have one in the numerator and one in the denominator. 5 times negative 2b, that's a negative 10b. And this is greater than 18 minus b. In inequalities, I would always recommend getting your variable on the left. So let's move this b over here. If these cancel, I have a negative 9b is greater than 18. So I'm one step away from having the b by itself. So what I'm going to do is I'm going to divide both sides by negative 9. This is something that you need to watch out for. Please watch out for this. If you divide or multiply both sides of an inequality by a negative number, you have to flip the inequality. So these will cancel. All I have left is a b, but because I divided by a negative, the greater than symbol flips to a less than. And then 18 over negative 9 reduces down to negative 2. So that's my final inequality. We were also asked to graph the solution set on a number line. So we'll start, nice blank number line here. Here's 0, Negative 2 is my number of interest right here. Two things that you need to remember for a number line. Open or close circle, shading to the left or to the right. So here, because I just have a less than, I'm going to put an open circle. I don't have the or equal to, so the negative 2 is not actually included. And then this is a less than symbol, which means I shade off to the left. So I am shading everything over here to the left. And then that would be my final answer. Number 9. Carson has $35 to spend at the water park. The admission price is $25. Each soda is $2.50. Write inequality to show how many sodas he can buy. So he's spending $25 no matter what. That's kind of like the flat rate fee. This is really similar to Rosa and her cell phone plan, if you guys remember that example. And then each soda is $2.50. So plus $2.50 per, let's do S for soda. And whatever money he's spending, he can't spend any more than $35. So we're going to say that whatever he spends has to be less than or equal to $35. If it's less than, that means he hasn't spent all his money. If it's equal to, that means he spends exactly the right amount of money. But of course, he can't spend more than the $35 he has because he doesn't have more than $35. So for number 9, all you were asked to do was write an inequality. We don't have to solve it. We don't have to graph it. So make sure you're looking at directions carefully. Number 10, we're going to solve this one. R minus 3 is less than negative 5, or 4R plus 1 is greater than 15. And again, just a reminder, that or does not mean that you get to choose which one you want to graph. This is an or compounds inequality. That's where you get the two pieces off to the side. So for this one, solve this piece by adding 3 to both sides. So first piece is R is less than negative 2, or whatever we get over here, start by subtracting 1. Remember, when we're solving equations or solving inequalities, we always add or subtract before we multiply or divide. So we've got a 4R left right here, divided by, is greater than 14, then divide by 4 on both sides. So we are left with R is greater than, remember I told you, if you do improper fractions, mixed fractions, decimals, doesn't bother me, whatever, it just needs to be a reduced fraction. So 14 over 4 reduces down to 7 over 2, or we could do 3.5, or 3.5, whatever you want. So let's put this together on an inequality. When you do the ors, what happens is you just combine everything up on one big equality. So here's the negative 2 for our first one. So R is less than a negative 2, which is actually the exact same thing we just graphed up above, but with a different variable. So we have an open circle in the negative 2, and we shade everything off to the left. And then here, 3.5. So we're looking at 1, 2, 3, 4. So we want to go halfway in between. It again is just a greater than, not a greater than or equal to. So I do my open circle, and then here I would shade everything off to the right. So remember those or graphs. They have the two pieces off to the side that look like ors on our rowboat. 11, solve. All right, here's our first absolute value inequality. So this one is a less than. So you've got the two different ways that these absolute value inequalities can be set up. They're extremely different, totally opposite from each other. So this one is a less than. Less than means we can go 11 units in either direction, but that's it. We want to be less than 11 units from 0. So we can go 11 units to the right, but no farther. We can go 11 units to the left, but no farther. So these ones get set up as a three-piece inequality. So we can go 11 units to the right, or we can go 11 units to the left. So negative 11 is the lower bound of our set. I can be anything in between, and positive 11 is the upper bound of our set. So when we're setting up these three-piece inequalities, the less than always turns into this. I take the stuff out of the absolute value and put it in the center. Then I put the positive version of this number right here, the negative version of this number right here. So I can go 11 units to the left or to the right, but that's it. Then when I'm solving this three-piece inequality, remember the way this works is whatever I do to the middle, I do to both sides. So my goal was to get this letter P in the center by itself. Got a 15 on the right. Got a negative 7 on the left. So that means any value of P between negative 7 and positive 15 would make this inequality true. So let's graph that. So here's 0. So we've got a whole bunch of marks in here. You guys know where this 15 is, somewhere around there. Whole bunch of marks here. The 7 would be somewhere there. Kind of space it appropriately. If you don't put every single value on there, at least keep it spaced. 15 is not the same distance from 0 as -7 is. So for these ones, I have or equal to's for both of them. So I'm going to put a closed circle on the -7, closed circle on the +15. The way that these work is that P can be anything in between, so I shade the center there, just like that. 12, we've got a multiple choice. It says which graph represents this inequality right here. First of all, this is a three-piece inequality. The three-piece inequalities always look like ands. So for this one, I could go through and solve it, and I can, just to simplify it up. But let me show you what the book looks like, and we can kind of eliminate some options, because that's really one of the most important things you can do for multiple choice. So since this is an and, we've got something on the left, something on the right, it's definitely going to look like one of these two. These are and graphs. H and I, those are or graphs. So we can eliminate those right away. H and J, definitely not a possibility. And then you'll notice here that the left one is just a less than, and the right one is a less than or equal to. So circle on the left should be open to match with the less than right here. The circle on the right should be closed to match with this one right here. So just by eliminating possibilities, I can figure out that it's option F without actually solving and simplifying and graphing and everything like that. So just by doing a little process of elimination, we can figure out that it's F. 13, another story problem. Sophia's buying new skis. She finds the average price of skis is $500, but the actual price could differ by as much as $250. Okay, so here's what we're doing. These ones that we talked about today in class, where we had to take a graph and then write an inequality based on that graph, it's very similar to this. So her skis, let's go S for skis, or I guess we could go P for price. So the price of the skis, the average price is $500. What that means is that 500 is the center of that graph. So I put an S minus 500. And remember, it seems kind of counterintuitive that I would put a minus 500, but think of solving this. If I set this equal to 0 and solve, I would get an answer of 500. So that's my center. So I have S minus 500, and then they differ from the average by as much as 250. So I know there's going to be a 250. Now it differs by as much as 250, which means it can go 250 up, it can go 250 down, but that's it. So when it follows that sort of pattern, it's a less than. And then it says as much as 250, so I would assume that the 250 would be included in there. So let's make that a less than or equal to. So when we solve this, this is set up very similarly to what we just did with number 11. It's a less than or equal to, it's got absolute values. Whenever we have the less than or equal to with absolute values, we start by taking this piece out of the absolute value, and then we trap it in between a positive and a negative 250, just like we did for number 11. Okay, so we set it up like this. Then our goal is to get S in the middle by itself. So whatever we do to the middle, we do to the right and we do to the left. So I get S in the middle. Negative 250 and positive 500 is a positive 250. Positive 250 and positive 500 is a positive 750. So what this is saying is that her ski prices will vary between $250 and $750. Which, if you read the way that's written, it should make sense. It says the average is the average is 500, but the actual price could differ by as much as 250. It could go down 250 from 500. It could go up 250 from 500. So that's the total range. She will end up with anything in there, and then this inequality was part of our answer as well. Okay, 14. We got another story problem here. Andy's making a garden. Let's set up this trapezoid here. Okay, label the exact picture that we've got. So 8 feet, 7 feet, 7 feet, 12 feet. So when it says he's making 3 trapezoidal garden boxes, the trapezoids look like this. It says it will be the size of the trapezoid below. He will place stone blocks around the borders of the boxes. So how many feet of stones will Andy need? So here's what we're trying to figure out. We're going around here, around here. This is essentially just a perimeter problem. So we need to add up the perimeter. He's got stones going all around here. So we got to do 7 plus 8 plus 12. We had all the edges all the way around, and that's going to be in feet once we get our final answer. But what people forget about is the fact that we mentioned at the very beginning that he's making 3 of these garden boxes. So we're going to take this, multiply everything that I get by 3. So according to the order of operations, I've got to add everything on the inside first. So 7 plus 7 is 14, plus 8 is 22, plus 12 is 34. So 34 is the perimeter of one of these boxes. All the way around is a total of 34 feet, but I have 3 of them. So I multiply 3 times 34, and what I end up with is 102. So 102 feet, that's how many feet of stones he will need to go all the way around that garden. That's number 15. Solve each equation. Okay, so here's our first one. This is an absolute value equation. So this one, the absolute value equations, a lot of time people will just forget that the absolute value stuff is even there. We need the absolute value stuff. It tells us that we have one positive answer and one negative answer. So the x plus 4, that's the distance from 0. This is saying that x plus 4 is 3 units away from 0. Now, scenario 1 is that the x plus 4 could be 3 units to the right, and it could be equal to positive 3. Scenario number 2 is that the x plus 4 could be 3 units to the left and that it's equal to negative 3. Every single time you do one of these, you should have 2 scenarios set up. One for the positive version, one for the negative version. Remember, if for some reason you are set equal to a negative, there is no solution, but we will see that in just a minute. So scenario 1, we go through, we solve both of these. We get negative 1 as our first answer. Subtract 4 from both sides here. And we get negative 7 for our second answer. Now, these ones, I recommend always that you check your solutions. We talked about how we kind of check them in our heads. We talked about how you can check them in your calculator. Since this is a pretty basic one, we can check this right in our heads. If we go to check, if we plug in the negative 1 for x, we want to see if it does come out to equal 3. Well, negative 1 plus 4, that of course is 3. The absolute value of 3 is 3, so this answer works. Check the negative 7. Negative 7 plus 4, well, that's a negative 3. And the absolute value of negative 3 is also 3. So this one works too. Just a quick little way to check your answers. 16, absolute value of 3m plus 2 equals 1. So this one, same thing, same exact thing. For scenario 1, you take the stuff out of the absolute value and you set it equal to the positive version of 1. For scenario 2, you take the stuff out of the absolute value and you set it equal to the negative version of 1. In both of these, you are just solving these equations. So here we subtract 2 from both sides. We get 3m equals negative 1. Divide both sides by 3. So I get m equals negative 1/3. That's one of my answers. Over here, I subtract the 2 from both sides. I get negative 3 when I combine the negative 1 and negative 2. Then divide both sides by 3. So for my second answer, that reduces down to a negative 1. All right, so same thing here. I could plug in both of those values, simplify them down. So if I plug in negative 1/3, I want to know if this equals 1. 3 times negative 1/3 is negative 1. Negative 1 plus 2 is 1, and the absolute value ends up being 1. So that one works. I could also plug in the negative 1 and see if this original equation holds. 3 times negative 1 is negative 3. Negative 3 plus 2 is negative 1. The absolute value of negative 1 is positive 1. So this one works too. 17. Absolute value of 3a plus 2 is equal to a negative 4. Now, I'm hoping I trained you well enough on these ones. This thing on the left-hand side, the absolute value, always positive. No matter what you plug in for a, the absolute value always comes out as something that's positive. So if this right here is something that's always positive, always a positive number, how could something that's always positive ever be equal to a negative 4? Well, it can't. These are the ones where you write no solution. And that's it. No setup required, no work required. If you've got absolute value set equal to a negative, it's automatically no solution. Okay, so here's another one of these. This one's slightly different because my absolute value piece is not isolated. I've mentioned this before, I'll say it again. The absolute value expression, this piece right here, has to be alone before I can set up my equations. So you gotta add this 7 first, otherwise your whole problem will be thrown off. Okay, so now that the absolute value piece is isolated, now I can set up my 2 scenarios, just like numbers 15 and 16. I take the stuff out of the absolute value, I set it equal to the positive version of 11. I take the stuff out of the absolute value. I set it equal to the negative version of 11. Then I'm just solving two equations here. Okay, and then divide both sides by 2. So my first answer is a 3. Next, I subtract 5 from both sides. This ends up being a negative 16. Divide both sides by 2. And what I end up with is a negative 8. Okay, so two answers there, a positive 3 and a negative 8. Okay, oh, they are just going hard on the absolute value equations, huh? Okay, here's another one. So same thing here. We've got to get that absolute value piece isolated before we set up our two equations. So we start by adding 6 to both sides. This is equal to 3. So because that's positive, it's a perfectly legitimate absolute value. So we set up our two scenarios. We take the stuff from inside the absolute value. We set it equal to 3. We take the stuff inside the absolute value, and we set it equal to negative 3. So here, when I add 2 to both sides, I'm left with a 5n on the left, gives me 5 on the right. Divide both sides by 5. These cancel. So I have just an n equals 1. That's 5 over 5. That's my first answer. Over here, I'm going to add 2 to both sides. So I get 5n is equal to negative 1. Divide both sides by 5. Again, these cancel. And then n is equal to a negative 1/5 or negative 0.2 for you decimal people. Okay, so those are your final answers there. These ones, just to point out a difference, because you may be wondering why we're not necessarily checking these ones in the calculator. The difference between these ones and one of the ones we saw in class, these all just have a number on the right-hand side, just a 3, just an 11, just a 1 right here. If you've got variables on the right-hand side, that's when you absolutely have to check on your calculator for an absolute value. Those ones could have extraneous solutions. It is a possibility if you have variables on the right-hand side instead of just a number. Like if this were like a 3n plus 1, you would need to check. You may have an extraneous solution. These ones, the only reason you'd be checking here is to see if you did any of your algebra wrong. I'm pretty confident about my algebra, but just so you guys know how this calculator check works, I am going to show you that. So, turn on, we are either opening up a new document, no, you don't want to save the old one, or you can always just add a page. So, let me get you in full screen, or full view of everything. So my first solution was this n equals 1. So I take the number 1, and then you store it in. So you hit Control first, and then you hit this variable button right here where it says STO up above it. Store that in as n. You can just take the n right from the alphabet pad, hit enter. So now every time you plug in the letter n, it thinks it's the number 1. So then we type in this equation, the exact original equation before we made any changes to it. Now, so not this one, but this one. Absolute value. See where the 9 is? Go 1 over to the right, hit that weird symbol key. Don't hit Control first, just hit the weird symbol key. Yours should be highlighted on the absolute value already. So just go ahead and hit enter. It gives you a brand new absolute value that you can fill stuff into. So we're going to type in the 5n minus 2. Then to get the minus 6, make sure you arrow over like this so your cursor ends up out of the absolute value. Then type in the minus 6 and then equals negative 3. The equal sign is right here under the control button. So equals and then type negative 3. Okay, so hit enter. And that is true. That is our first answer that we get, and it turns out to be true. Next one, we've got the negative 1/5. So when we do this negative 1/5, make sure you give me a fraction. So negative, then hit Control divide to open up a fraction, 1 over 5. So that's a negative 1/5. Store that in as n now. Hit enter, so now it wiped out the 1, replaced it with negative 1/5. So now what we do is we arrow up, see how it's highlighted and everything blue. I've got my equation highlighted in blue. When I hit enter, it's going to copy paste it. I can check one more time, and that one is also true. Okay, so just a quick way to check those on your calculator. So we are moving right along here. We are on number 20 now. So number 20, we've got one more of these. So this one, just like the last two, you cannot set up an absolute value inequality equation, until this thing is by itself. So absolute value of p plus 6 equals negative 1. Well, we can stop right there because the absolute value cannot be equal to a negative. So it's automatically no solution. So we had to do a step to get ourselves there because we had to get this absolute value piece isolated first. Geometry. Okay, the volume of a cylinder is given by the following formula right here. It says what is the volume of the cylinder below, and it gets you all of those values. So it says the radius, now let me show you this picture, just in case you don't have your book. The radius is only from the center to the outside of the circle, so this one is sort of trying to trick you, I guess. This is the diameter that it gives you, the 12 centimeters. The radius is only half of that. So if this whole length is 12 centimeters, half of that length is 6 centimeters. So that is the radius, 6 centimeters. And then the height is given, it's lying on its side, and the height is that 9 centimeters. So we plug that right in here into this equation. We plug 6 centimeters in for R. We plug 9 centimeters in for H. And then we solve for the volume. So this, you don't have to include units. I just think that including units helps you figure out what your final units should be. So here, we're going to take that 6 and square it. So pi, and then we get 36 centimeters squared. So now I square the 6, which is 36. I also square the centimeters. That's, again, just playing around with my units. So whatever I get here, I need to multiply the pi times the 36 times the 9. So let me show you some of those buttons again. So the pi, right down here by the H. So press that button. Gives you kind of a weird menu. The first one you select is the pi, and then times 36 times 9. We always want to hit Control before we hit Enter so we can get a decimal approximation. There's a very, very big value there. I want 3 decimal places. So 1017.876. Go to 3 decimal places. So 1017.876, and that would be in centimeters cubed, which you can see if I'm working with these units right here. Centimeters squared times centimeters gives me centimeters cubed. 22, we've got a negative 3b minus 5 greater than or equal to negative 6b minus 13, and then graph the solution set. This is just one of the simpler inequalities. This isn't absolute value or compound or anything like that. So here, let's get the variables on the left-hand side. And then let's get the constants over to the right-hand side. So what happened is I lost my variables from the right, but I end up with a 3b on the left. I lost my constants from the left, but I end up with a negative 8 on the right. And I still have my greater than or equal to, because all I did was add and subtract, which doesn't change the inequality. Then to get the b by itself, I divide both sides by 3, so these 3's cancel. Then I have b is greater than or equal to a negative 8/3. Or, if you're a mixed fraction person, negative 2 2/3. We don't want to be decimal people on this one, because you'd have to round the answer. We don't want to round the answer, because it's 0.666 repeating. So to graph this, here's 0, here's negative 1, negative 2, negative 3. This is going to be right around here, 2/3 of the way between negative 2 and negative 3. And then it is greater than or equal to, so we shade everything to the right over here. I always say include the arrows so that it shows that you're going on forever. 23, we've got another one of these evaluating problems. If x equals 2/3 and y equals negative 2. So this is just like one of the first ones that we saw. You want to replace every x with a 2/3, every y with a negative 2. So this is definitely going to be trickier because of that fraction. Okay, so all we did there was we replaced the x and the y. So starting inside this set of parentheses right here, let's do a little side work over here. 2/3 and then plus a negative. Now instead of 2, we would really like it if it had a denominator of 3. So we're going to multiply 2 by 3/3. That way I get a negative 6/3. Which if you reduce that down, negative 6/3 is just a negative 2. I just did this so that I can get the same denominator. So this ends up being negative 4/3. Okay, so let's simplify that down. 3, and then in parentheses I get a negative 4/3. That's from combining these two up. Over, first thing I do in the denominator is I take care of that exponent. So negative 2 squared is negative 2 times negative 2, which is positive 4. Next, I'm going to start multiplying. So in the numerator here, I'm going to multiply 3 times negative 4 over 3. Well, when that happens, the 3's will cancel. So I have negative 4 over 4 times 2/3 and then times 4. So remember, I've got different properties that tell me if I want to multiply 4 times 4 first, I can. So let's again do a little side work for this. 4 times 4, of course, is 16, and then times 2/3. So let's write this over 1 so we can multiply together. So this ends up being 32 over 3. So when I multiply 4 times 2/3 times 4, what I end up with is 32 over 3. So again, this one is a tricky one. I'm dividing by a fraction. Instead of dividing by a fraction, what you want to do is you want to multiply by its reciprocal. So dividing by 32 over 3 is the same as multiplying by 3 over 32. Think of this as negative 4 over 1, so I can multiply fractions. Last thing is that 4 and 32 share a common 4. So it's now negative 1 here over 8 when I reduce those both down by 4. So negative 1 times 3, of course, is negative 3, and then 1 times 8 is 8. So that one was definitely tricky, but that's your final answer there. Number 24, name the sets of numbers to which negative 1/3 belongs. So we've got a bunch of different sets of numbers. We have the natural numbers, that's the innermost. Those are just the positive non-zero whole numbers, 1, 2, 3, 4, 5, 6, etc. Then we have the whole numbers, which are all those numbers plus 0. Then you have the integers, which are the positive and negative whole numbers, negative 7, positive 4, positive 10, negative 22. This is not any of those because it has a denominator of 3. The first one that this falls into is the rational numbers. The rational numbers are anything that can be written as an integer over an integer, or a fraction of integers. And then it automatically falls into the real numbers. All of them are real numbers. So they're first either irrational or rational, but all of them are reals. So these are the only two that fraction falls into. And number 25. Okay, so we've got this nice little chart down below. What quantity of beads does the accessory store have a better deal? Okay, so we're supposed to be using the inequality they give us here. So here's what we're trying to figure out. They give us this table, but then they give us the inequality anyway, so it's not like we really have to set it up. What it says with the accessory store, and I'll put this under again. With the accessory store, you pay $15 for the chain. That's a flat cost. You only get one chain. Then you pay $3.25 per bead. Less expensive chain, more expensive bead. With finishing touch, you pay more for the chain, but less per bead. So eventually, what we're trying to figure out is how many beads would you have to buy for the accessory store to end up being the better deal. So what they set up here was we've got, this is for the accessory store, $15 flat rate plus $3.25 per bead. This is the finishing touch, $20 flat rate plus $2.50 per bead. We're trying to figure out for what quantity is it the better deal. So here, when is this one going to be less than this one? Or otherwise, when would it be the better deal? Well, when you pay less. So we always want to get the variable over on the left. So we're going to subtract $2.50. And then we're also going to subtract the 15 over to the right so we can get our constant over there. These will cancel. These will cancel. If you had $3.25 and you subtracted $2.50, what you would have left is 75 cents times b is less than, and then this ends up being 5. Okay, so divide both sides by 0.75 to get the b by itself. Now this I would totally understand if you guys plugged this right into your calculator, because I know that dividing whole numbers by decimals is probably not your ideal thing, but what you could do, see if you follow me on this one, 0.75 is equal to 3/4. Hopefully we know that. So 5 divided by 0.75 is the same as 5 divided by 3/4. And just like we did in number 23, when you divide by a fraction, what you're really doing is multiplying by its reciprocal. So instead of dividing by 3/4, I'm actually multiplying by 4/3. We can put this over 1. We end up with 20 over 3. So a couple options here. b is less than, we've got 20/3. Or you can say that b is less than 6 2/3, or you can say that b is less than 6.75. 667 if you just plugged it right into your calculator and got a decimal. But basically, this is saying you can buy up to 6.667 beads. Well, you're never going to buy 6 2/3 beads. You're either going to buy 6 beads or you're going to buy 7 beads. If you buy 6 beads, it still falls within this inequality, but as soon as you buy 7 beads, what that means is that the other store is the better deal. So you can really only buy 6 beads or fewer. You always have to kind of think on your toes with the story problems to figure out whether they actually can be fractions or not. You can't buy 2/3 of a bead, so you can only get 6. So 6 beads or fewer, and that first store would be a better deal. All right, so I know that this is not on there, but I actually just want to find one problem, because with number, where was it? Oh, it must have been on the first half. With number 11 and with number 13, you guys got to see an example of the absolute value that had a less than or equal to. For some reason, these review problems didn't have an absolute value that had a greater than or equal to. So this one I'm going to pull off of page 52. We are going to do number 52 on that page. So this one, just to give you a taste of the absolute value that has a greater than, just because for some reason they didn't have that on there. Okay, so here's that problem. First thing you have to do, just like I mentioned with the equations, is that you've got to get this away. This absolute value piece needs to be by itself. So to get rid of the 1/3, you multiply by 3. Do that to both sides. These cancel. All I have is this piece right here, and it is greater than or equal to 7 times 3, which is 21. When I have the greater than piece, remember, this is the worst thing ever, but maybe it will help. Greater than, it looks like the OR graph if you have a greater than symbol. So the OR graph has 2 pieces. You've got one piece or the other piece. The first piece, you take the stuff out of the absolute value. To get the left wing of the OR graph, you need anything that is less than or equal to negative 21. I've said this in class many times. The less than freaks people out because it starts off as a greater than. But what this original inequality tells us is that it wants 8q plus 5 to be at least, that's what the greater than or equal to says, at least 21 units away. So if we go 21 units to the left, we land at negative 21. To get farther away, we have to go farther to the left, meaning we have to go less than 22, 23, 24. So that's where that less than comes from. Or you take the stuff out of the absolute value and set it greater than or equal to 21. That one's usually easier for people. You go out to the right 21 units, you're at 21. If you keep going to the right, you're at 22, 23, 24. That's at least 21 units away. So at least 21 units to the left, at least 21 units to the right. We can set these up. So here, subtract 5 from both sides. We get a negative 26. Divide both sides by 8. Now this does reduce, so I can reduce it down to what, negative 13/4, I guess. And then what we're looking at here is we need to subtract 5 from this one. So we get 8q is greater than or equal to, this is going to be a 16. This one comes out nicer at least. So this one just ends up being a 2. Now back over here, if you are more of a mixed fraction person, we could write negative 3 1/4, negative 3.25, whatever. So let's go to graph these. So here's 0. We can go up 2. So this piece right here says we can be greater than or equal to. So the or equal to says we shade. The greater than we go off to both sides. I'm sorry, to the right, not both sides. Here's negative 3, negative 4. So negative 3 1/4, just do your best, maybe right about there. And then the less than says that we shade everywhere to the left. So now just on this one, because I told you that the interval notation would pop up as well, let's talk about how to put this in interval notation. So this piece over here, we want to know how far our graph goes to the left. Well, we shaded our arrow to show that it keeps on going forever to the left, so negative infinity, which I put parentheses on, because I always have parentheses with negative infinity. Then it goes all the way up to negative 3. And I put a bracket around negative 3 because I have a closed circle, which means the negative 3 is included in my solution set. Then I put a little union symbol, and then get ready for this one here. This one starts with 2, and it includes 2. So again, I put brackets right here, comma, and then it keeps going up to the right, and so it goes up to a positive infinity, which always has parentheses. Okay, so We covered the practice test. We got one extra problem. If you have any other questions, please, please, please come in the morning. I will be there by at least 6:30, maybe even earlier. All right, good luck. Happy studying.